Hi everyone. In this video we're going to go through part 2 of 14.4, focusing on Z-scores. So in this section of the video we are going to relate the area under a normal curve to Z-scores and make conversions between raw scores and Z-scores, and then in part 3 we'll focus on some sample problems. Now there's a lot of words on this slide, so go ahead and pause the video if you want to read through them first. But we refer to Z-scores as features of the standard normal distribution. When you find Z-scores, you're essentially standardizing your data set to have a mean of 0 and a standard deviation of 1. Right? If we talk about females aged 30 to 39, they may have a certain mean and standard deviation for a set of females. But when you find Z-scores within that data set, you normalize it to have a mean of 0 and a standard deviation of 1, not whatever the mean happens to be within that specific data set. And we use tables that I'll show you on the next slide to give the area under the curve between the mean and that Z-score. All right? And the Z-score represents the number of standard deviations that a data value is from the mean. And like the example that we have here is if I have a normal distribution that has a mean of 450, so that's the mean, and then the standard deviation is 25. If I have a score of 500, that is 2 standard deviations above the mean. And the reason for that is because if I take 450 plus 25 and plus 25 again, because 25 is the standard deviation, I get 500. So my score of 500 is 2 standard deviations above the mean, and therefore it corresponds to a Z-score of 2. All right, here is the Z-score table. This is a portion of the table, and it gives you the area under the standard normal curve that is between the mean and the Z-score that I find. And so what I'm going to do at the top here is I am going to draw my normal distribution that I always draw fairly poorly. It wasn't too bad, but that is my normal distribution. And the mean, of course, is in the middle. And in our standard normal distribution, the mean is 0. Okay, and let's say that I have some score over here, some positive Z-score on the right. Maybe the first one we'll do is 0.85. Oops, wrong. Let's see. Let's go 0.85, like that. Okay, so 0.85 is the first Z-score that we'll look up. And when we find that on the table, what that is going to tell us is the area of this region, how much stuff is between the mean of 0 and a Z-score of 0.85. All right, and how you find that on the table, first I'm going to start in the Z column, and I'm going to go down to 0.8. Okay, Z equals 0.85 is what I gave you, and so now I'm going to go over to the 0.5 up here. So I'm going down the Z column to find 0.8 first, and then across to 0.5, and where those two meet. So going across 0.8 and going down the 0.5, they meet right here at that number, 0.3023. And what that number represents is the area inside of that region, 3023. All right, and I think drawing the pictures for these problems will be especially helpful and in my opinion, necessary. All right, let's go through another example where we convert some Z-scores to areas. And again, I think for each one of these, it will be really, really helpful for you to draw this little picture. Even if you don't do it that well, draw your distribution like that so that you can label Z equals, in the case of A, Z equals 0, and Z equals 1.3. All right, so I'm finding the area between the mean and a Z-score of 1.3. So I'm going to go down to my table, which gives me the area between a mean of 0 and a standard and a z-score. But I need to find 1.3 first. So I go down the left-hand column, 0.1, 2, 3. Oh, let me get my pointer. 0.1, 0.2, 0.3, 4, 5, 1.0, 1.1, 1.2, 1.3 is right there. And since I don't have anything after the 3 in my z-score, I'm going to assume that is 1.30. So that's how that works. 1.30 is right there. Let me just add circles. 1.30, and those meet at that z-score, or at that area right there, 0.4032. All right. So on my picture, I'm going to label this area is equal to 0.4032. All right, and that's it. That's all you have to do for A. It's not always that easy, but in the case of A, that's all the work that we have to do. All right, now let's take a look at B. B is a little bit different. Let me draw my distribution again. I'm going to draw a new one. This is how I show my work. Okay, so my next one, I'm going to add the mean of 0 on there, even though the question doesn't ask me about that. But now in this one, it's z equals 1.5. So I'll draw my dotted line down there for 1.5. And z equals 2.1, which would be somewhere over to the right of that. And it's not absolutely crucial that you put those numbers in the exact perfect spot for where they would be on the distribution. Just get that roughly accurate. So for part B, we want to be between 1.5 and 2.1. So the way that we do that is we're going to look up an area for both of them. So for z equals 2.1, we're going to find a corresponding area. And for z equals 1.5, we're going to find a corresponding area. And then I'll pause my talking for a second. Think about what we'll do with those areas. Okay, what we're going to do is when we look up 2.1, it's going to give me all this stuff, right? And when we look up 1.5, it's going to give me this stuff. And so to just get that area over there, we're going to subtract. So I'm not subtracting the z-scores. I'm going to go ahead and subtract the areas once I have them. All right, so let's do that. So let's go over here. I need 2.1 and I need 1.5. Good, I was hoping I could keep them on the screen. All right, so 2.1 is right there. 2.10 is that number. So my area is 0.4821. 4821. And then 1.5 is right there. And there's nothing after the 1.5. So that's my area, 0.4332. All right, and so to finish off part B, all we need to do is subtract 0.4821 minus 0.4332 is equal to 0.0489. And so that is the area of the region that I have circled in red and I'm now scribbling in as green. So that's about 5% of the area under the curve. 0.04 is close to 5%. All right, good deal. Now, one more part to this problem. Part C is the first one that deals with a negative z-score. Let's see. Part C, I'm going to draw my distribution again. Maybe we're getting better at it by now. Maybe not. We'll see. That's okay. And label my 0 in the middle. And now my z-score is negative. So that negative, I'll put it right about there, negative 1.83. All right. Notice my table doesn't have any negatives on it. That's okay. This distribution is symmetric. So if I look up positive 1.83 on the distribution, it's the same, right? It's the same or it's the same area either way. That's supposed to be an 8 there. Just kind of got messy, right? It's the same on both sides. The area that I'm shading over here in blue is the same as the area that I am shading in red, even if in my poorly drawn picture it doesn't quite look that way. Okay, so now we need to find 1.83. So here is 1.8 right there, and then here is the 0.03 column. That's the top of the chart there gives me accuracy to the nearest hundredth. Going down the side gives me accuracy to the nearest tenth. So I follow that down, and we get that the area is equal to 0.4664. There we go. So 46% of the area is between 0 and negative 1.83. All right, so that's how that works. Good. The last part of this video deals with converting raw scores to Z-scores. So if I have a raw score, if I have a score from some data set, how do I find the Z-score that corresponds to that? Well, we get this fancy schmancy formula, Z equals X minus mu over sigma. So I take my data point, subtract the mean, divide by the standard deviation. In the example from earlier in the video, the score that we were looking at was 500 minus the mean was 450 divided by the standard deviation was 2. That was from earlier in the video. If you or the standard deviation was 25, excuse me. If you do that subtraction, you get 50, divide that by 25, and you find an answer of 2 for the Z-score. Now let's take a look at an example where we find a couple of Z-scores given raw data. So you can pause and read through this example if you want to. I'll highlight the important parts. We're told that this data set is normally distributed, and we have a mean of 20 pounds and a standard deviation of 3 pounds. So I can write down that important information that my mean, mu, is 20 pounds. Standard deviation sigma is 3 pounds. And for part A, we have to find the Z-score corresponding to a weight of 25 pounds. So let me rewrite that formula. Z equals X, the data point, minus mu, the mean, over sigma, the standard deviation. So substituting in my numbers, 25 minus 20 divided by 3, that's 5 over 3, which is, what's that going to be, 1.6 repeating. So I'll round that to 2 decimal places, 1.67. And that's it. That's our Z-score. If the problem asks for more, we would then need to go to that table that I have on the last, or 2 slides ago, and go from there and find the area that corresponds to that Z-score. But we'll save that for the next video where we put these 2 pieces together. Okay, for part B, for our 16-pound, what are these, dog, we're going to do the same thing. Z equals X, the data point, 16, minus mu, the mean, 20, divided by sigma, the standard deviation. 16 minus 20 is negative 4. The negative matters here. Now, because we're below the mean, our Z-score is negative. And negative 4/3, let's see, the Z-score is negative 1.3 repeating. I'll round that to negative 1.33. Okay, so we could mark those on our normal distribution. We could draw it out and mark them on there. But like I said, we'll save that for the next video where we put it all together. All right, that is the end of this video. Thank you very much for listening. Work on the homework problems. Let me know if you have any questions. Have a wonderful day.